All right, to begin, you want to start by importing all the libraries that are required. These include pandas, numpy, re, seaborn, matplotlib, and warnings. Just off the bat, I'm going to let you know that warnings isn't completely necessary, but I'll encourage you to have it because it just makes life easier. Smoother for the code itself, okay? And these libraries have different cases to be used. So this one would help with data analysis. This one would help with the mathematical functions when it comes to actually making your model, okay? These help with it checks patterns in different forms of text, okay? And then these two would be data visualization, okay, which you'll see later. And once you've done that, you want to actually look and read and load your data set onto the program you're using. Now, depending on what you're using, it's going to be a bit different. So let's say you're using Google Colab or Jupyter, you might actually have to upload the data set on it first and then do this step. So look into that. But I'd encourage you to use Spider if you can because it's actually really, really neat. It lets you know any errors that you have. For example, this one is technically an error, right? But it's just because we haven't really used it in our code because all our code is commented out. But once I slowly begin to uncomment it out, you can see that these would disappear, right? And another thing, the most important thing for me is the variable explorer. Okay, so sometimes when you assign your variables, you want to see what's going on if the variable really has what you assigned it, right? And so you put a print statement, and that's just a separate line of code. But let's say you run this, right, like I did just now. There's nothing here, so that's good. But you see you have a variable in your variable explorer, and if you open it, you can actually see the whole data set. You can see that your model just now read it, your program just read it, and there you have it, different languages, different texts, and in total there's 10,337. So the next step is to count the values of all the languages. So similar to what I just showed right now, we're going to run it again, and you can see that the value count has been shown to us. And this just says how many characters there are of each language. So you can see Hindi here has the least amount, whereas English has a lot, okay? All right, and after that, we're gonna be separating the independent and dependent variables. So separating text and language. So let me run it and show you what it looks like. Okay, so dependent, which is our language, you can see that these are all the languages in the code, right? There's a whole bunch. I'm just going to use this right here. So you can see there's too many. Okay. And the independent would also be similar. So you have all the text. And these would correspond with each language. So I don't remember if you saw, but there's a whole bunch of English on the top. And we had a lot of English over there as well. Okay. Now we want to do the next step, which is converting categorical variables to numerical. So computers understand numbers better than they understand actual words, right? So this just essentially makes the life of a computer easier. It just makes it easy to understand, right? Because for us, we might like English, but for computers, they probably want numbers, okay? So I'm just gonna run it here and show you what that does. So you can see the dependent variable turned into an array of int 64. This basically means it's turned into a whole bunch of numbers, right? So colorful. Okay. Now, this would be probably the most important step to make your model accurate. So if you miss this, it's gonna cost you later on. So don't miss it. Okay. To start off, you want to make an empty data list, okay, or an empty list, and I'm gonna label it data list. And then you want to go through each text in the independent variable, which is where all your texts are, right? So if I click this right now, you can see that there's some numbers like right here, and there's like those brackets. Now, when we're speaking or just typing language, we don't really have numbers, and when we do have numbers, it doesn't translate. You just know they're numbers, right? And symbols, same goes with symbols. So what this for loop does is it goes through every single piece of text in the independent variable, and then it removes all the symbols and numbers. So if you see the nature, the quotations there or the numbers there, they're probably going to be removed after we do this step, okay? Because after it does that, it also turns everything into lowercase, because again, to make the lives of our models easier, we always want to make it into either lower or upper. It just makes sense to put it in lower, right? And then we're going to append it to the list that we created above here. Here. And yeah, so let me run it for you and then we'll see the list. As you can see, all of the text is basically lowercase, and most of the unimportant symbols, just hyphens or quotations or things like that, they've been removed. The next step is to make a bag of words model, which makes representation easy, and half of the time it doesn't follow any grammar, and most importantly, it makes text into a bag of words so that our model can learn better from just random words rather than a structured sentence. Next step, most important step in any model, okay, is to split your data set into training and testing sets, okay? Usually some people do 50-50, 80-20, right? Here it's the test size is 20% and the rest is going to be used for training. You want to have more for training, right? And then you're going to train your model and predict the output of the test set, okay? This step is going to take a while to learn, but I'm just going to give you a little analogy on how it works, okay? So think of training the model as doing homework in a math class, okay? You're doing your homework and the homework is given, based on your curriculum or your syllabus, okay? And then when your model predicts it, you're basically taking a test, right? Like, let's say you're learning linear functions in training. This is your linear function test, okay? So that itself is gonna take so much. But then when it comes to your actual results, you want to test the accuracy. So evaluating the accuracy of your model is similar to saying your test results, essentially, okay? Like, that's how I like to think of models, okay? So the evaluation of the accuracy, right, is just gonna see everything and then it's gonna see your accuracy. So I'm gonna run all this and it has printed the accuracy of the model. So for this one, it's about 97%, which is great. It's absolutely great. 97. Nothing can be perfect, and if it can be, then it's probably not real. Okay, so that's great. The accuracy is great. We're probably not gonna need it to print accuracy every time. So once you've actually known the accuracy, I would just comment it out. Okay, now I'm sure you remember my analogy from before, how these steps are, homework, test, this is test results. Now, some teachers like to have a rubric, right? So that is like saying plotting the confusion matrix. So that being said, I like to think of a confusion matrix as a rubric, okay? It's just telling us the accuracy, but it's showing it as a visual, right? It's gonna be more detailed of how exactly the model is functioning, right? Okay, so you can see this is our variable explorer, but we also have a plot tab. Again, really, really helpful. So let me just zoom in. Okay, well, I cannot zoom in, but here is your confusion matrix, right? It looks good. It's just a whole bunch of math, right? For now, don't really need to know it, but just know how this is how your model is functioning.